Phase difference of waves. First, I want to link circular motion to waves. Here I have a disk with a red dot on. The disk and dot will rotate, and here I'll plot the vertical displacement of the dot against time. If we label this position as 0 degrees, the starting point, this part of the graph then relates to 0 degrees. 90 degrees up here would relate to this position, 180 degrees would relate to here, 270 degrees to here, and then this would be back to 0 degrees or 360 degrees. Now I've added a second dot to the disk, which is 90 degrees behind the first dot. If I map out the displacement of both these dots, this is what we get. So now if we look at these two peaks, we'll see that the red peak is at 90 degrees, while the blue peak is at 180 degrees. So these two peaks are 90 degrees apart from each other, and we say that these waves are 90 degrees out of phase, or they have a phase difference of 90 degrees. Now we have the two dots 180 degrees apart on the circle, and if we map out their displacement, we get this. The two waves always oppose each other and would destructively interfere to give zero displacement. The red wave has its positive peak at 90 degrees, the blue wave has its positive peak 180 degrees away from this at 270 degrees. We say that the waves have a phase difference of 180 degrees. Now the blue and red dots are together on the circle, and if we map out their position, we get this. They now have a phase difference of 0 degrees, or 360 degrees, or even n times 360 degrees, where n will be a whole number. We say that the waves are in phase. They would now constructively interfere. You sometimes get the phase difference of waves given in the alternative angular measurement of radians, where no degrees would be the equivalent of no radians. 90 degrees, or a quarter of a rotation, is pi by 2 radians. 180 degrees, or half a rotation, pi radians. 270 degrees, 3 pi by 2 radians, and a complete rotation is 2 pi radians. So, as we produce our wave from the circular motion as before, we can add on this point is 0 radians, pi by 2 radians, pi radians, 3 pi by 2 radians, and the complete rotation 2 pi radians. So two waves completely out of phase could be described as being 180 degrees out of phase, or pi radians out of phase.